Okay, we're going to start more on Part B on section 2.2. And we've learned about entering a matrix into our calculator. All right, so that's what we're going to do now. We're going to first construct the matrix. So here I have 1, 1, negative 1, 3, and negative 13. On the second row, I have a 3, a negative 1, a 1, and a 1, and a 5. On row 3, I have a 5, a negative 2, a 1, a negative 3, and a 16. Okay, now this guy right here is going to give us a little bit of a problem because this is going to be one of those matrices that is dependent. I have fewer rows than columns. Fewer rows than columns. So it's going to be a dependent system. And instead of Z, we've got the W. So let's see what happens in our matrix. We can work it by hand, but it would take a little bit, and I would like to do this by calculator. So we have a 3-row by 1, 2, 3, 4, 5 column. 3-row by 5 column. So we're going to enter it. Second matrix, edit, enter. And this is a 3 enter, 5 enter. And I'm going to do a 1, 1, negative 1. Make sure it's a negative. 3, negative 13, 3, negative 1, 1, 1, 5, 5, negative 2, 1, negative 3. So I entered it. So now I'm going to check, making sure. Oh, wait, I missed something. Oh, 16. Sorry about that. Didn't finish 16. All right. My last column is negative 3, 13, 5, and 16. 3, 1, negative 3. Negative 1, 1, 1. 1, negative 1, negative 2, 1, 3, 5. So I've got a good output there. So I'm going to capture that screen so that if you look at my completed notes, sorry about that, I'm going to copy, sorry, and I'm going to paste it right there. All right, so this is my 3 by 5 matrix entered. All right, so now I have that. So I'm going to do the second quit and be on the home screen. I'm going to do second matrix math and go up arrow till I see the RREF, reduced row echelon form. And I'm going to name it second matrix enter A. Make sure it's that, and I'm going to enter. All right. So I'm going to capture this screen. We know it's dependent. Oops. Cancel. I want to copy and then delete it. All right, so I'm going to make my mark right there and paste it. All right, so here I have, make some room. So here I have my solution. And you can see that I have x plus w equals negative 2. So I want x in terms of w. X equals negative 2 minus w. So this is one of my solutions. The other one is y plus 6 w's equal negative 15. Therefore, y equals negative 6W minus 15. I went ahead and put the W in front, and it's just to make it look, it doesn't matter how you write it. Sign goes with the number, so it's going to be correct. All right, so I have my second one. My third one is, let's see, what do I have? Z, sorry about that, plus W, 4 W's, equal negative 4. Z equal negative 4W minus 4. So now I have all of my solutions. They are, in terms of W, the last variable, negative 2 minus W, negative 6W minus 15, negative 4W minus 4, and W. All right, so that's what we have in this form. Is everybody comfortable with that? Righty. So now we have next to our last problem here, and it is a word problem. So I'm going to clear my home screen and let's see what it says. To get a necessary funds for a planned expansion, a small company looks at 3 loans totaling $26,000. Company owners were able to get interest rates of, so here are our interest rates. X amount is at 4%. Y amount, if I could write, you all would have a perfect instructor, wouldn't you? At 5%, and Z amount at 6%. All right, so we have X amount plus Y amount plus Z amount equals to the amount of the total loan. All right, now they borrowed, the company owners were able to get interest rates of those. So this is 0.04x plus 0.05y plus 0.06z equal, okay, let me see, what do we have there? Borrowed company owners. The amount of interest on the loans was $12.60. All right, that's what that is. Now, they said this. They borrowed 1,000 more, 1,000 more at 5% than they borrowed at 6. So 6 was Y, was Z. This one at Y. All right. So we have 1,000 equal to Y minus Z. Y minus Z. So that's our last equation. Right. So now we have what we needed. I didn't answer them in the order they wanted, but we got it all okay. So now they want a solution. So we're going to draw our matrix. 1, 1, 1, 26,000. 0.04, 0.05, 0.06, $1,260 interest. 1 minus 1, 1,000. It's an augmented matrix. All right. So we know this guy is a 3 by 4. All right. So now we're going to enter it. We're going to go second matrix and we're going to edit. Enter. And it's a 3 by 4. Now we're going to enter what we know. 1, 1, 1, 26,000. Careful on these things. 0.04. Sometimes my calculator misses a dot and I don't catch it. That one is 1,060. And then we have 0, 1, -1, 1,000. Right. So let me capture that screen. Okay. So there is all of that matrix entered. So I'm going to go on my home screen and I'm going to go second matrix, math, REF, and enter second matrix A. All right, and enter. So we can see that they borrowed $11,000 at 4%, 8,000 5%, and that definitely is 1,000 more than 6, because this is 7,000 at 6%. If I add it up, I get $26,000. All right, how's that? Everybody breathing? Everybody good? Okay. Now remember, you can pause this anytime and rewind it at any time so that you can get clarity on what I'm saying. All right. So here's the B part. Suppose we drop the condition that they borrowed 1,000 more than at 5% than they borrowed at 6%. What would you say about the amount at 6%? What is a solution if the amount borrowed at 6% is $6,000? All right. So what we have now is the following. We have 11,000 at that, and all of that. So on our list, have to have x minus z is 4,000. Plus okay, so they're saying if they borrowed, they didn't do that, and at 6%, and 6% was 6,000. Okay, so instead of it being 7, it's reduced by 1,000. All right. All right, then 6%. What is the solution if the amount borrowed at 6,000? Okay, first, there's two answers to this one. What would you say about the amount borrowed at 6%? All right. Well, if we kept everything else the same, we'd have to change a lot of things. All right, because we wouldn't know, well, we would know that, okay, this is the same, this is the same, this is not the same. So what would we have if it's not? What can you say about the amount borrowed at 6%? All right, then we would say that they would have to be equal, right? In other words, the 1,000, there's 1,000 difference there. So 7,500 for both 5% and 6%. Would that be viable? Would we have a solution? Or would we have something affect what is happening with the rest? So I would say that would happen. So let's go back and state that that we have 50 more, right? 50 more. So that would make it 500 more. So that would make it 1,000 between them. So how would we state that? Let me think about that a minute, because our solutions are that. What if we took away the 1,000? All right, well then, if we took away the 1,000, then 1,000 plus, what did we say up here? Z, Y. So we would have, oh, I see what we'd have. Okay. Then our matrix changes to this equals that. So that's a negative Y and a positive Z. Y minus Z. So we'd have the same matrix, so we would have Y 1 minus 1, 0. They'd be the same. So would it work? Let's find out. Second matrix, edit, and we would enter. And instead of the 1,000, we would get 0 right there. And enter. Second matrix. Oops, sorry. Second matrix, math. Go to RREF. Sorry about that. Second matrix, RREF, second matrix A. Solve it. And we get this. And we go math frac. And they would be given a third of everything. Everybody would get the same. And then it says, what can you say about the amount? Okay, that one, it was all of them would have the same. What is the solution if the amount borrowed at 6% is 6,000? So if we're saying this is 6,000, all right, and that would make it 7,000. Oh, I don't know. What would happen? All right. Okay, so what would we have? The amount borrowed at 6% must be greater or equal to 11,000. The amount borrowed at 6 must be less than or equal to 4,000. Yes, that is correct. The amount borrowed, because if we did it, they'd have to be the same, which would make it in that range. The amount borrowed at 6% to be less than equal to that. No, that's wrong. The amount borrowed at 6 must be greater than or equal to 4,000. So it has to be this one here, the last one. Or wait, less than. It'd have to be this guy right there. Less than or equal to the 11,000. Because if we divided by 3, we're getting pretty close. All equal. All right. That one was tough. Thank you very much. That was a tough thought one, but we got it. I appreciate all the work you do. Now you can do the homework. Thank you for listening.